Okay, this video we're going to look at maximum and minimum problems where the function is unknown. Here's some steps to take. First of all, draw a diagram if necessary, because they can really help out and help understanding. Identify the quantity to be maximised or minimised. So what are you finding the maximum of? Express this quantity in terms of one variable only, and that's the tricky bit. Oftentimes in these questions you'll have two variables. You've got to narrow it down to one before you can do the next bit, which is solve the derivative and make it equal to 0 and solve for x there. Okay, so f dash x equals 0. And you can only really do that if you get an equation in terms of one variable. This will make more sense when we do some examples. Verify it as a maximum or minimum using a gradient table. Sketch a graph on the calculator if required, and then answer the questions that are required after you've done all the work finding maximum and minimum. Alright, here's an easy example. The sum of two positive numbers is 10. Find the numbers if the sum of their squares is a minimum. So what I've done here straight up is just label the two numbers x and y. And if their sum is 10, we therefore know that x plus y equals 10. Therefore, if we want to find out what x is in terms of y, and that's the next step, or y is in terms of x, we have to swap this around. And what I'm going to do here is get y in terms of x. So y equals 10 minus x. Okay, so we've now got the one variable, x, and we've equated y with 10 minus x. Okay, so we can now get everything in the same variable. Because what we're finding here is find the numbers if the sum of their squares is a minimum. So instead of putting x squared plus y squared, okay, that's the sum of their squares. The problem with that is we've got two variables, we've got x and y. What we need is to get one variable. So the sum of their squares, instead of being x squared plus y squared, will be x squared plus 10 minus x squared. Okay, so we've got it all in terms of x. So going back to my steps, we've done step 3 here, which is really important. Express the quantity in terms of one variable only, and then we're up now to step 4. Okay, but before we do that, we're going to do a couple of other things here. We're going to have to label our equation here, or form an equation. Okay, I'm going to call it S for sum. So the sum of x, the squares of x, is x squared plus 10 minus x all squared. Okay, so here's the function that I'm dealing with. So just copy that over to the next slide. We'll move on. Okay, here we go. Okay, so there's the equation. S of x equals x squared plus 10 minus x. Next thing we need to do is remove the brackets there. So we get x squared plus 100 minus 20x plus x squared equals 2x squared minus 20x plus 100x. So I've now got my equation for the sum of the squares in this situation. So what we're going to do now to find minimum, s dash x equals 0. So if we get the derivative, 4x minus 20 equals 0. Therefore x equals 5. That's our suspected minimum value for x. Okay, the value of x, which will make the sum of the squares a minimum. Now, what we have to do is show that value of x does provide us with a minimum. So to do that, we set up a gradient table. Okay, we suspect that 5 is our minimum, so we'll put 5 there. And we put values either side of 5. 5 provides us with our minimum, so its gradient there is going to be 0. So we have to look at what happens to the gradient at 4, value x equals 4 and the value x equals 6. So we have to work out s dash 4 and s dash 6. Okay, s dash 4, we put 4 back into the derivative, not the original, remember. We get 4 times 4 minus 20. That equals 16 minus 20 is negative 4. Okay, so we've got a negative value there. S dash 6, 4 times 6 minus 20, value of 4. Positive gradient there. So our slopes are negative, 0, positive. Okay, so x equals 5 is a local minimum because of that pattern, negative, 0, positive. So to go over that again, our original task was to find the numbers. We haven't quite finished yet, by the way. The sum of two positive numbers is 10. Find the numbers if the sum of their squares is a minimum. So I let x equals the first number, y equals the second number. We therefore know that x plus y equals 10. At the moment, we've got two variables. Okay, we've got x and we've got y. So what we have to do there is get them all in terms of the one variable. So if x plus y equals 10, we know that y equals 10 minus x. So then instead of x squared plus y squared, we've got x squared plus 10 minus x squared. We've got a little equation now which gives us the sum like so. Tidy up that equation was the next step. Okay, whoops. Next step. Then make that derivative, or make the derivative equal 0, solution x equals 5. Set up a gradient table, look at the patterns of the gradients. Now, we haven't quite finished, as I said, because we know from the start that x plus y equals 10. Alright? So we know that x equals 5 gives us a minimum, so 5 plus y equals 10. Therefore, y also equals 5. So answer, x equals 5, y equals 5. So the two numbers are both 5. Okay, next question. A rectangular sheep holding pen is to be constructed along the side of a shearing shed. In order to save materials, the side of the shed will form part of the side of the holding pen. The shearing shed is 20 metres in length and there are 80 metres of fence materials available. Diagram, guys. Here it is. Okay, so a rectangular sheep holding pen, okay, and see that is here. If I just put a little tick there, you can see that's the holding pen, is to be constructed along the side of a shearing shed, which is there, SS for shearing shed. In order to save materials, the side of the shed will form part of the side of the holding pen. You can see that's what I've drawn there. The shearing shed is 20 metres in length and there are 80 metres of fencing available. Right, so I mentioned back in the steps that we have to go through that drawing a diagram is important, and I've done that there. Show that the area of the holding pen is given by A equals negative x squared plus 50x. Now, commonly in exams, they will give you an equation to work towards because, of course, this question will have a lot of different parts, and unless you get that equation, you won't be able to answer the other parts. So, oftentimes, a reassuring thing is that they can give you the equation that you're working towards. So, without reading it on in the questions, we might do that first. Show that the area of the holding pen is given by that equation. Right, let's start. Now, we know that the shearing shed is 20 metres in length. So I can label that as 20 there. Okay, which means, of course, that 20 is also there, the length of the shearing shed. So if I'm using 80 metres of fencing, there's 20 metres that I don't have to use. Okay, let's label my diagram here. What I might do is label this length x, okay, and then this length we can call y. Sorry, the width is y, and we've got 20 from there to there, as I said. So what this little length here will be is x minus 20 from there to there. Let's make those arrows clear. Okay, so that's x minus 20. So if I just draw a red line here, you'll get the message here that that length there is x minus 20. Wow, so what does all that mean? Okay, well, what it means is this. The length of my holding pen is x and the width equals y. But we've got two variables. I want to get everything in terms of x. Now, one fact we haven't used yet is a fact in the question here, that there are 80 metres of fencing available. So let's use that now to get things together. Alright, so what is going to make up that 80 metres? Alright, well, it's going to be x. Okay, I'm going to use my red again. So x plus y. Okay, so that's my y there. Plus x minus 20, which I've already got in red there, so I'll just do another line there so you can see it. Okay, plus x minus 20 plus y. Okay, it's another red line there. Okay, plus y. What does all that equal? That equals 80, because that's what I have to make my fence out of. I don't have to worry about the shearing shed. That's going to form part of it. The parts I've marked there in red have to add up to 80. The x plus the y plus the x minus 20 plus the other y over here. Okay, that's going to equal 80. Now, getting that equation enables me now to get it down to one variable, because if I collect all that together, we now get 2x plus 2y minus 20 equals 80. 2x plus 2y equals 100 if I take the minus 20 across. 2y equals 100 minus 2x. Y, if I divide through by 2 now, equals 50 minus x. So, ladies and gentlemen, what that means is the length is x, the width, which is y, is 50 minus x. Area is length by width. Area equals x times 50 minus x. Okay, equals negative x squared plus 50x. We have answered question A. Pink square around it. Show that the area of the pen is negative x squared plus 50x. Okay, down here we have just done that. We're now up to the second part of the question, which is determine the dimensions of the holding pen so its area is maximised. Okay. Maximum derivative equals 0. So let's go here. We now know, we knew before, but we've now proven that the area equals negative x squared plus 50x. So to find maximum, we have to get the derivative, so dA dx, and make it equal to 0. So that's going to be negative 2x plus 50. We now make that equal 0, so negative 2x plus 50 equals 0. 2x would equal 50. Therefore, x equals 25. Okay. Let's see if that's a maximum or minimum, so we have to set up a gradient table. So let's do that now. Okay, so this gradient table, it's only got 3 columns because we're dealing with a quadratic graph, okay, an x squared graph there. So we don't need 5 columns as we sometimes do with a cubic graph. Okay, so, oops, get a bit straighter. Ooh, keeps going crooked on me. I'll get it eventually here, guys. Bear with me. That'll do. Alright, so we've got our x, okay, our derivative, which in this case we call dA dx, and our slope. 25. Now we can pick a number less than 25. Let's look at 20. and 30 is our higher one. Okay, so if x equals 20, the dx equals, remember we're putting it into the derivative, negative 2 times 20 plus 50, that equals positive 10. So that's a positive answer. We know that 25 will give us 0, because that's our suspected maximum. Down here, if x equals 30, dA dx equals negative 2 outside of 30 plus 50 equals negative 10. Okay, so negative answer there. So our slopes are going to be positive, 0, negative. Okay, so let's copy that over to the next slide to have a closer look. Oops, sorry. Right, so there's our gradient table. So that's established that x equals 25 is a local maximum, okay, because we've got plus 0, negative. Now, remember we had to get our dimensions, and I've still got my diagram here, so we've now established that the length, x, is 25. So what's our width? Well, back over here, remember that y, if I put a square around it here, y equals 50 minus x. So if we've got, if we've got x equals 25, therefore y equals 50 minus x, which is minus 25, also equals 25. Okay, so our dimensions, width equals 25 metres, length equals 25 metres. Now we have to answer question C, which is maximum area. Area is length by width, 25 times 25 equals 625 square metres. And we're done.